Welcome back to the Deep Dive. Today, we are diving deep, really getting into the weeds on some of the toughest architectural challenges in cloud security.
Yeah, the kind of stuff cybersecurity architects wrestle with daily.
Exactly. So if you're looking for maybe a shortcut to really mastering those critical decisions in Azure security, especially the really complex high-stakes scenarios, then this is definitely for you.
And we're not just skimming the surface with generic advice here. We're really drilling into specific required solutions. Think highly compliant, highly automated environments.
Right. Our source material today, it's all centered around the core concepts you'd find in, say, the Microsoft Cybersecurity Architect domain. We're pulling out the definitive architectural choices for, 5 key security pillars?
5 major pillars, yes, covering things like automation, governance, identity, the works.
Okay, so our mission here is pretty clear.
Right.
Extract those essential tools, the architectural strategies you absolutely need to build secure, compliant, and importantly, automated cloud environments. Doesn't matter if it's pure Azure or a hybrid setup.
And we're pushing past just the what. We really want to get into the crucial why. Why this specific tool is often the mandatory choice, maybe over other options that seem similar.
Good point. Let's start right at the front line then. The Security Operations Center, the SOC.
Ah, the SOC. It's interesting. The biggest headache for a modern SOC isn't usually a lack of alerts.
Oh no, it's the flood, right? Just this
Right.
overwhelming volume, which leads straight to that classic problem, alert fatigue.
Precisely. You've got all these tools maybe generating thousands of low-level warnings every single day.
And a human analyst, they just can't
Yeah.
possibly triage all of that. It's impossible.
Right. So for an architect designing a resilient SOC, maybe using Microsoft Sentinel, the real challenge is scaling the analysis. How do you turn hundreds, maybe thousands of these sort of low-confidence warnings into one single high-confidence incident?
Something that actually warrants immediate attention, whether that's human or automated.
Exactly. The architecture itself needs, integrated intelligence.
Yeah.
Trying to handle that sheer velocity manually, it's just not sustainable.
Okay, so what's the architectural answer there in Sentinel?
Well, the first key feature relies heavily on the Microsoft Sentinel Fusion Detection Engine.
Fusion. Sounds punchy. Marketing aside, architecturally, why is that the key? Couldn't we just, write a bunch of standard correlation rules?
You could try, but standard rules are often too rigid, too brittle for today's threats. Fusion, it's different. It uses machine learning, pretty sophisticated correlation logic. Think of it like a digital detective.
Yeah.
It connects these seemingly unrelated little signals like maybe a suspicious file access here, a weird login attempt over there, some strange network traffic across different tools, different products.
And ties them together.
Yes. It combines them into one unified high-fidelity incident. The real insight is that this ML-powered correlation, it's really the only effective way to genuinely reduce that alert noise and fight fatigue when you're operating at cloud scale.
Okay, so Fusion figures out what the serious threat actually is. But, okay, once you know it's serious, time is critical, right? We're talking seconds, not minutes, before an attacker might escalate.
Absolutely. You need an instant response.
So that moves us beyond just the security information and event management part and into SOAR territory. Security orchestration, automation, response.
Precisely. SR takes the baton right after Fusion confirms a high-confidence incident. In Sentinel, we use automation rules that trigger playbooks. These playbooks are actually built on Azure Logic apps.
Right, the workflow engine.
Exactly. So for a really high severity confirmed threat, the playbook can immediately execute a pre-approved response, like automatically isolating a compromised virtual machine, pulling it off the network.
Without waiting for an analyst to even see the alert, maybe?
Correct. No waiting for someone to wake up, log in, click a button. It's immediate automated action.
Okay, so that's the core takeaway for an efficient SOC, architecturally speaking. It's that two-part punch. Fusion for the high-quality detection, cutting through the noise. And then automation rules and playbooks for that immediate, hands-off, high-impact response when it really matters.
That's it. It shifts the SOC from just reactive reporting towards, proactive automated defense.
Okay, that makes sense. Let's pivot now. From reacting to threats, let's talk about proactively maintaining standards. Governance, risk, and compliance. GRC.
GRC, always a fun topic. This is where we focus on keeping the environment aligned with specific rules and standards.
And this can get really tricky, especially for regulated industries. Imagine you're running workloads that absolutely must comply with something like NIST SP-853 or maybe PCI DSS or a specific national standard.
Right. And the requirement isn't just, checking for compliance once a quarter. It's about continuous monitoring. And this is the key part, actively enforcing those security configurations all the time.
That word enforce, that feels like the crucial distinction here. Lots of tools can report on compliance, right? Like Microsoft Defender for Cloud gives you a secure score, tells you what's wrong.
It does, and that's valuable information. But reporting is fundamentally reactive. It tells you after something is already broken or non-compliant.
Okay.
So if the requirement is truly continuous active enforcement, something that actually prevents non-compliant things from happening and can automatically fix configuration drift, then there's really one standout Azure service.
And that service is?
Azure Policy.
Azure Policy. Okay, but why policy specifically? Why not rely on the reporting in Defender for Cloud, maybe combined with some scripting?
Because Azure Policy functions differently. Think of it less like a reporter and more like the building code inspector who has the authority to actually stop work on site.
Ah, okay. I like that analogy.
It operates right at the Azure Resource Management layer, and it does two critical things that pure reporting tools can't. First, it uses these things called deny effects.
Deny effects.
Yeah, they literally prevent a non-compliant resource from even being deployed. So, if your policy, based on NIST, says all VM disks must be encrypted, policy will just block the deployment if someone tries to create a VM without encryption.
Ah, so it stops the problem before it starts.
Exactly. And second, let's say a resource is compliant when deployed, but later someone changes a setting, maybe accidentally, and it drifts out of compliance. Policy can use its modify or deploy if node exists effects to automatically remediate that violation. It can actually fix the configuration.
Wow. Okay, so it's not just a warning light on the dashboard. It's an enforced boundary. That's how you maintain that consistent governance posture that standards like NIST demand.
Proactively. It essentially creates a mandatory security baseline that the environment simply cannot violate. That's crucial for any kind of audit or strict compliance mandate.
Okay, the architectural need for policy in that context is crystal clear. All right, so if policy keeps our infrastructure compliant, the next challenge is often the application itself and the sensitive data it might handle. Let's move to Section 3, layered defense.
Yeah, a classic defense in depth scenario often comes up here. Let's say you've got a new business application and it's processing highly confidential customer data, maybe financial records, personal info, that sort of thing.
Right, highly sensitive.
And you typically have two distinct requirements. First, protect the app from external web attacks. Second, protect the sensitive data even from internal folks, like developers, who might need access to production systems for troubleshooting, but shouldn't see the raw sensitive data.
Okay, two layers needed. Defense at the network edge for the app and defense inside the database for the data. Let's take the edge first. Protecting against common web exploits, SQL injection, cross-site scripting, usual suspects. What's a mandatory Azure service for that?
For that specific web application protection, you're looking at the Azure Application Gateway Web Application Firewall, or WF.
The App Gateway Way.
Correct. Think of the way as like a specialized security guard just for your web app. Its job is to inspect the incoming HTTP and HTTPS traffic very closely, looking for malicious patterns that a standard network firewall probably wouldn't catch.
Because it understands web protocols deeply.
Exactly. It proactively blocks those common attacks, SQL injection, cross-site scripting, XSS, and others right there at the perimeter before they even get close to your actual application servers.
Okay, so Way handles the inbound attacks. Now, what about that second requirement? Protecting the sensitive data itself from, say, developers querying the production database for diagnostics. How do we make sure they only see sanitized data, not real customer account numbers or PII?
Right. That specific requirement, controlling internal visibility of sensitive data within the database, is met by Azure SQL Database Dynamic Data Masking.
Dynamic data masking, is that a separate product?
No, it's actually a built-in feature of Azure SQL Database itself and some other Azure data services too. It works by, masking or redacting specific sensitive fields in the query results just before they're sent back to the user.
Ah, so the data in the database is still intact, the real data is still there?
Precisely. The underlying production data remains untouched, fully secure. But the development team, or maybe a support person running a query, they only see a masked version, like credit card numbers showing up as XXXXXXXXXX1234.
Got it. So architecturally, we achieve layered security. The WARE at the network edge, protecting the application from external threats.
Mm-hmm.
And then dynamic data masking inside the database, protecting the sensitive data from unauthorized internal viewing.
Ensures you can operate without compromising compliance.
It's a really good example of defense in depth, but tailored very specifically to protect both the application layer and the data layer beneath it.
Excellent pairing. Okay, let's move on to what's arguably the most critical and often the most complex control plane, identity, especially when you throw legacy systems into the mix.
Oh, yeah. Privileged identity architecture, especially in a hybrid world, it's frequently the trickiest set of decisions an architect has to make. You're trying to bridge modern cloud security practices like zero trust back to sometimes decades-old domain infrastructure. Yeah. Let's tackle that exact scenario then. Picture a big, maybe multinational company. They're using on-premises Active Directory domain services, good old ADDS, and they've synchronized it with Microsoft Entra ID in the cloud.
Pretty standard hybrid setup.
Right. But here's the critical requirement, the non-negotiable bit. They need just-in-time, or JIT, access for their server administrators, but specifically for managing the highly privileged accounts on those on-premises domain controllers.
Okay, that's the key constraint. On-premises domain controllers. If this were purely cloud-based, managing Azure resources or Entra ID roles, the answer would be simple. Entra ID Privileged Identity Management, or PIAM, easy.
But PIAM is for cloud resources, right?
Primarily, yes. Because the target for this JIT access is those critical, highly privileged roles inside the on-premises ADDS environment, Entra ID PIAM by itself can't directly manage or enforce those access policies on the domain controllers. It needs a bridge.
So what's the essential solution? The piece that extends that JIT principle, those cloud security controls, back to the on-prem AD infrastructure.
For this specific scenario, the required solution is Microsoft Identity Manager, IAM Privileged Access Management, PAM.
MIM PAM. Now, some might think MIM is older technology.
It's been around, yes, but it's absolutely necessary here because it is the dedicated, purpose-built system designed specifically to implement and enforce just-in-time access and temporary privilege elevation for administrators managing those sensitive on-premises Active Directory roles.
So MIM effectively provides that secure, audited workflow, like a secure checkout and check-in process for admin rights.
Exactly. It lets an admin request temporary elevation, it goes through an approval workflow, and they get the permissions only for a limited time, only when needed.
And the big benefit is drastically reducing that risk from standing access, accounts that have permanent admin rights on the most critical servers, like domain controllers.
Precisely. It shrinks the exposure window for your most powerful on-premises accounts right down, which is fundamentally applying that zero trust principle of least privilege and JIT access directly to your legacy infrastructure administration.
Makes sense. A crucial bridge for hybrid identity security. Okay, one last major architectural pillar. Let's talk network topology.
All right, the network.
We've got one final non-negotiable requirement. All internet-bound traffic, both inbound and outbound, what's often called north-south traffic, originating from any service in Azure, whether it's infrastructure as a service VMs or platform as a service offerings, must pass through a single centralized inspection point. And this inspection point needs serious capabilities. URL filtering, malware inspection, and intrusion detection and prevention, IDPS.
Right. The mandatory requirements there for IDPS and likely TLS inspection as well for proper malware standing, they immediately narrow down the options significantly.
Because not every firewall service offers those.
Correct. To get those advanced threat protection features, especially in a centralized hub model, you absolutely need to use Azure Firewall Premium.
Okay, Firewall Premium, that's component one. It acts as that central security gateway, providing the heavy lifting, the TLS inspection, the IDPS, the advanced URL filtering, basically vetting all that traffic going in and out.
It meets those mandatory deep inspection requirements, but just having a powerful firewall doesn't automatically guarantee that all traffic actually goes through it.
Good point. Centralized security is kind of useless if application teams can just create their own routes to the internet and bypass the inspection point entirely.
Exactly. So component 2 is needed to ensure that traffic is properly segmented and, crucially, forced through that firewall premium, and also to enforce access control down at the subnet or even network card level. That complementary service is network security groups, or NSGs.
NSGs. So they work hand in hand with the firewall.
Absolutely essential. Think of NSGs as the traffic cops and the lane dividers on the highway. They enforce strict access rules, allow or deny based on IP address, port, protocol, right at the subnet level, and the individual network interface, NIC level.
Where they control the flow.
They control the flow. They're essential to make sure that, first, only authorized communication happens between different network segments, microsegmentation, and second, that any packet trying to get to the internet or maybe back to on-premises is explicitly blocked unless its only allowed path is directly through the Azure Firewall Premium for that mandatory inspection.
Okay, so the architectural insight is that these two services, they're really symbiotic. They depend on each other.
Totally. The Firewall Premium provides the advanced, deep inspection capabilities you need to meet those tough security requirements like IDPS and malware filtering.
Right.
And the NSGs provide the essential segmentation, the microsegmentation, and the routing enforcement needed to make sure that central firewall is actually effective and unavoidable for all the traffic it's supposed to inspect.
Which I guess leaves us with a final, maybe provocative question for you, the listener, to think about. Considering all these mandatory enforcement mechanisms we just discussed, how many of your own organization's security tools today are truly enforcing policy?
Versus how many are just, well, reporting violations after they happen.
Understanding that the difference between monitoring and active, automated enforcement that feels like the core challenge and opportunity in modern cloud architecture.
Definitely something worth exploring in your own environment.
Indeed. Well, thanks for sharing your sources and insights with us today. That's all the time we have at this deep dive. We'll catch you next time.